Hello everyone, this is my assignment. It contains two parts. The first part on the left hand is about approaches to integrative STEM, and the second part on the right hand is about a flow chart for integrative STEM unit planning. And I want to start with the first part. Integrated STEM education combines science, technology, engineering, and mathematics into a cohesive learning model. It emphasizes the connection between these disciplines by focusing on real-world problems that students can solve using knowledge from all these areas. This method aims to prepare students for today's complex issues and engage them more deeply by showing how STEM is related and applicable to daily life. STEM education is all about bringing together science, technology, engineering, and math in a way that makes sense. There are different ways to mix these subjects to help students understand better. The big ideas model is like creating a theme for learning. Instead of seeing math, science, and the rest as separate, we see them as a parts of a big picture, working together to help us understand big concepts. Then there is the nesting doll model. Imagine each subject is a doll with math at the very center. As you open each doll, you find another one inside, adding more to your knowledge. So you start with math, add technology, then engineering, and finally science, making your understanding bigger and more complex each time. The Poly system model shows how connected these subjects are. It's like a group of bullies working together. When you learn something in a science, it helps you understand something in technology, and that helps with engineering, and so on. Everything moves together, showing that these areas need to work as a team. Putting all these ideas together shows that combining these subjects is better than teaching them separately. It's like making recipe better by mixing the right ingredients. This is what we aim for with STEM education, especially now in Saudi Arabia, where we are trying to teach these subjects together to meet the needs of our world today. Now let's move to the balanced representation of disciplines. In integrating STEM education, it's important to give equal importance to each discipline. While mathematics is fundamental, it should not be reduced to only serving science and technology. Its concepts must be taught thoroughly. Similarly, engineering needs to be highlighted more in schools, focusing on its design principles. The goal is to create a curriculum that combines these disciplines in a way that allows students to understand each one deeply and see how they work together to solve problems. And now let's move to the STEM processes. In integrative STEM education, various processes from different fields come together to form a complete approach to learning. For example, the engineering design process, which is all about refining solutions through repetition, works hand in hand with the scientific inquiry, which focuses on understanding problems. Computational thinking helps with the logic behind problem solving, while design thinking offers a user-centric perspective, and systems thinking provides a broad overview of how everything is connected. Integrating these processes helps the students think critically, understand complex ideas better, and apply what they learn to real-world situations. Now let's move to the global significance in learning context. In a world where problems know no borders, STEM education is key to preparing students for global challenges. A project like designing a solar-powered shade for parks in Neom, aimed at 9th and 10th grades, is a great way to teach important STEM concepts. This project is part of the Saudi curriculum and mixes math, science, and engineering in a practical way. Students will use geometry to figure out the best way to set up solar panels based on the location and the sun's path in Neom. They will also use algebra to estimate how much energy these panels can produce and how that can keep park facilities running. This isn't just about numbers, it's about applying math to real life problems. The science part involves understanding how solar energy works, which is crucial for inventing new things in the future. They will also get to use modern design software, which helps with digital skills needed in the job market today. This project is also about connecting to the bigger picture. It's linked to Saudi Arabian Vision 2030 and helps the students see how they can make a difference in their country. Through the engineering design process, students will learn that it's okay to make a mistake and that trying again is a part of learning. This kind of problem solving is what education experts like Tsing talk about when they say learning should be about the process, not just the results. It's about teaching students to think, work together, and be ready for the future STEM jobs. In the end, this project is about more than just learning. It's about preparing the students to learn the way in building a sustainable future for their country and for the whole world. When we talk about starting a STEM program that combines science, technology, engineering, and math, it's kind of like planning a big trip. Number one, start by reviewing the national standards for STEM and align them with the school's own goals. Assess what the school has in terms of resources and what it needs. Number two, determine what is lacking in the current STEM offerings by getting feedback from school leaders, teachers, and the students, and checking if you have the necessary physical and digital resources. Number three, outline how different STEM subjects can be connected at various grade levels. Set clear goals for what the program should accomplish and ensure it can work with the school's facilities. Number four, create lesson plans that combine elements from science, technology, engineering, and math around central themes. Use technology like 3D printers to enhance learning. Number five, train teachers in new teaching methods specific to the integrated STEM approach and provide them with the necessary instructional materials. Number six, allocate funds and resources sensibly to ensure all students can participate in the program and to support its long-term approach operation. Number seven, start the program and have teachers lead project-based learning activities, adjusting the approach based on how well the students are engaging and learning. Number eight, use practical real-world assessments to gauge students' progress and the effectiveness of the program and make improvements where needed.